Hey guys. So I'm gonna run through the answer key for both of these exams in case you guys want to cross-check your answers um, from when you completed it on your phone. Okay, so let's jump into it. Question one, we have two different points on a line and we just want to find the slope. How do we find the slope of a line? Change in y over change in x. So you take the difference between your two y values and divide it by the difference between your two x. And your final result ends up becoming -9 over +6, which is reduced to -3/2. Let's move on to part B, where we're asked to find the equation of the line. And what we should do here is let's utilize our point slope formula. Y minus y1 is equal to mx minus x1. We already calculated our slope to be -3/2. Our point x1 comma y1 is either of these points since both of them lie on the line. So why don't we just use P, which is -4 comma 3. And now we just plug in to solve. So I'll zoom in a bit more. We get our y minus 3 in parentheses. Sorry, y minus 3 is equal to -3/2 in parentheses x minus -4, which is the same as x plus 4. Now we just want to simplify. So we get -3/2x minus 12/2, and then we're going to bring the 3 over. So we're looking at -3/2x minus 6 plus 3. And finally, we arrive at our slope-intercept form, -3/2x minus 3. And we're done. All of you guys should be crushing this section of the midterm exam dealing with our linear functions. Part C is just asked to graph this function. So I'm just going to copy and paste our equation from our previous slide. So we have easy access to it. And so how do we graph lines? Well, we utilize both the y-intercept as well as your slope. Our y-intercept is equal to our b value, which is -3 as a coordinate point. That's 0, -3. Anytime you're graphing, you need to put in a proper scale, otherwise you will not yield full credit. This is a very easy way to get full points, or even to just get partial points for a question. Label your x and y axes, and then we can go ahead and now plot our y-intercept. Always plot your y-intercept first, and then look at your slope and plot your additional points from there. Down 3 over 2, or up 3 to the left 2, up 3 to the left 2. And now let's connect the dots. Don't forget to put arrows at the end because all lines go on forever in both directions. And then write out the equation, 3/2x minus 3. And we're done. Really? This is our line L. Now, part D is asking us to identify both the x and the y intercepts. So x-intercept is at -2, 0.
That's the one.
Our y-intercept is, we already plotted it and wrote it off to the side, 0, -3. And then finally, we're on our part E, where we're being asked, is the line 3y minus 2x equal to -9 parallel to line L? Well, what do we know about our properties of parallel lines? All parallel lines have the same slope, which means line L, again, has a slope of -3/2. Let's see if we put our 3y minus 2x equals -9 into slope-intercept form and get the same slope. So inverse operations, add 2x to both sides, and we get 3y is equal to 2x minus 9. Divide both sides by 3, and we get y is equal to 2/3 x minus 3. Have the same y-intercept here, but not the same slope. Our slope is actually negative reciprocal, so it actually happens to be perpendicular, not parallel. So, no, not parallel, since slopes are not the same. You always want to properly explain your answer. Tells me that you actually understand the problem itself. Right, let's move on to the second question, where we're given a function and we're asked to identify the domain of a function. We're pros when it comes to finding domain and ranges of functions at this point. Domains always have two restrictions. Denominator can never be equal to 0, and when we're dealing with square roots, we don't want any negative value underneath roots, square roots, or just roots of even indexes or indices, because then we enter into the imaginary world. Okay, so do we have a fraction here? We do, which means that in our denominator cannot equal 0. And then we have no negative numbers under even index roots. Okay. So lucky for us, there are no roots here, so don't have to worry about that second condition. We just have to make sure our denominator isn't 0. So x minus 4 is not equal to 0, which means x can't be 4. That's our only restriction. So in interval notation, this is just all values from -infinity to +4, not including 4, so soft bracket, union 4 up to +infinity. And we're done. Now part B is asking us to find the inverse of this function. How do we find inverse functions? Well, we swap out our x and y's. Thank you. And then we want to isolate our new y. So we have x is equal to y plus 5 over y minus 4. Cross multiply. And we're looking at y plus 5 is equal to x in parentheses y minus 4. carry out some distributive property on that right-hand side. And let's subtract 5 from both sides, but let's also subtract xy from both sides. So we're essentially looking at y minus xy is equal to negative 4x minus 5. And so at this point, you can clearly see that you can factor out a y on the left-hand side. And when we do, we're left with 1 minus x in our parentheses. And we don't have to touch that right-hand side. Now, our last step before we put it into proper inverse function notation is we want to isolate that y, and we'll simply do that by dividing both sides by 1 minus x. So our final result, you can write this a few ways if you wanted to factor out a negative from the numerator. You could have that 4x plus 5 in parentheses. But either of these would work. It's just you really want to make sure that you put it into proper function, inverse function notation. So f inverse x is equal to either of these solutions.
You good?
And we're done. Bring it down here into the answer key too. Okay. Let's move on to part C, where we're now asked to find the range of f of x and the domain of f inverse of x. And so this is a really fun question because when you're looking at a function's domain and range, the inverse function's domain and range are just swapped. So what does that mean? That means that the range of your original function is the same as the domain of the inverse function. And we're very, very good about finding domains of functions because we have those two requirements, those two restrictions, and then we convert it into interval notation and we're done. Range, for the most part, is definitely a more visual concept where you want to see what are all of the possible y values. However, because we have this property between our original functions and our inverse functions, they're the same. The domain of the inverse is the same as the range of the original. So let's just find the domain of the inverse, and we have our answer. What is the domain of this function? There are no roots here, so we just look at what makes the denominator 0, which is just when x is equal to 1, which means x can't be 1. So what is our domain? Everything but 1. Negative infinity to 1, union 1 to positive infinity. And that's your solution for both the range of your original function and your domain of the inverse. Continue. Next question, we're dealing with a cosine related function. However, this is just identifying or asking us what the range is. Again, graphical standpoint, what are all of our possible y values here? You have the graph, you just look at it, and then you're good. The lowest value is -4, the highest is positive. So our range is just all values, including both -4 and +4, and all values between them. Now we want to list the intervals on which f is decreasing. So if you read a book, you read it from left to right. Same thing applies when you're reading a graph, left to right. So where on the graph does it go from up to down? We have over here. And we have over here. So I'll highlight, maybe I'll highlight it in red. These are our two decreasing intervals. So how do we write this? We are looking at all values from 0 to, what value is this? Pi. And from 2 pi to 5 pi over 2. And we have to pi. And 2 pi to 2. Let me just double check that last pound. Is that right? 3 pi over 2, 4 pi over 2. Yeah. 5 pi over, sorry, 6 pi over 2, which is 3 pi. And we're done. Part C, is there a local min or is there a local max at x is equal to 3 pi? 3 pi is over here. No, but there's a local minimum. If yes, then write yes below and state what the local max is. So no, there is a local min at x equals 3 pi. And the local min is -4. Let's move on to question 4. Find the domain of each function below and write your answer using interval notation. So no fraction here, which means we can exclude the denominator not being equal to 0, but we do have an even root index. And so what does that mean? Underneath that root needs to be greater than or equal to 0, which means subtract 3 from both sides and we get x is greater than or equal to -3. From a number line perspective, close that circle at -3 and shade all values greater up to infinity. Interval notation, this is represented as hard bracket -3 up to infinity. And we're done. Do part B. It's an odd root index, so we could have negatives underneath that root, but it cannot be 0 because 0 makes it undefined. So 1 minus 2x cannot be equal to 0, which means 2x cannot be equal to 1 and x cannot be equal to 1/2. That's our only restriction. Everything else is free game. So we have our domain as follows. All values from -infinity to 2, not including 2, sorry, to 1/2, not including 1/2, union 1/2 to infinity. Now we're on to our question 5, where we're given a table and we're asked to calculate some composition of functions. So think of the outside as your parent and the inside is your child. Let's calculate f of 2 first. So f evaluated at 2 gives you 3. And so now we're calculating g of 3. G of 3 gives us 6. Next question, if g of x is 2, so if g of x is 2, then find x. Well, our x is just 4. Find f of 6. So when x is 6, what's our f at 6? 3. And then we're asked to find the average rate of change between x1 and x4. Average rate of change is the difference between your two y values over the difference between your two x. F of b minus f of a over b minus a, which is essentially f of 4 minus f of 1 in this case, all over 4 minus 1. F evaluated at 4 gives you 1. And f evaluated at 1 gives you 2. So we have 1 minus 2, all over 4 minus 1 is 3, which gives you negative 1/3. And then we have part E. If G inverse of x is 4, then find x. So now, again, your x's and y's are switched when you're dealing with inverse functions. So now we're just essentially looking at, okay, if our input, right, is that 4 value, what's your output for g of x? It's 2. So x equals 2. These types of questions on the exam, if you know how to read your table, you can solve these questions within a few minutes. Okay. Question 6, we're given a quadratic function. We want to rewrite our f of x in standard form by completing the square, or can use the formula axis of symmetry, negative b over 2a. Standard form is just another way of putting it into our vertex form, a in parentheses, x minus h, close parentheses squared, plus k. And so our a here is 1, our b is 2, our c is negative 3. And why don't we complete the square? We haven't done a lot of practice with that yet. How do we complete the square? Just to recap, bring that constant over. Lucky for us, our leading coefficient, our a value is 1. So no division is necessary. Let's use our special key, which is b over 2 in parentheses squared. Our b is 2, so 2 over 2 simplifies to 1, and 1 squared is just 1. That's what we're adding to both sides. So now we can officially complete the square. That left-hand side is just factored into x plus 1 in parentheses squared. And that right-hand side is just 4. So if we bring everything over to that left-hand side, we get our standard form. Our y is equal to, our a value is just 1, so we don't have to write that in. And then we have our x minus h, which is minus negative 1 in parentheses squared, minus 4. wanted to put the A in, you could. But simplify, this is just x plus 1 in parentheses squared minus 4. And we're done. Now we're asked to sketch this graph. So let's utilize our axis of symmetry, negative b over 2a, negative 2 over 2, which gives us negative 1, which is our h value of our vertex. And then if we plug it in, we'll get negative 4, right, is our y value of the vertex. But I'll show you how that's the case by just plugging it back into your function. 1 minus 2 minus 3 gives you that negative 4. So our vertex is just simply negative 1 comma negative 4. Our axis of symmetry, that vertical line that splits our quadratic function in half perfectly, is at negative 1. So why don't we lock that line in?
Yeah.
I'm gonna write a proper scale so I can get full credit.
All right.
Label my axes.
Thank you.
Let's plot our vertex, negative 1 comma negative 4. Our A value is 1, which is greater than 0. So we're going to have a U-shaped quadratic. And then our y-intercept is at negative 3, which means if we reflect over that axis of symmetry, we get negative 2 comma negative 3 as another point. And we do anything else? Yeah, why don't we plot our x-intercepts? So we can factor this quadratic into x plus 3, x minus 1, which gives our x-intercepts at negative 3 and positive 1. And now we can just connect the dots. So more than enough points to show our graph of our quadratic. Our last step is we want to write out the equation. Label, always label your graphs. And then it says to label your vertex too. So our vertex is all the way at the bottom. We have a minimum at coordinate negative 1 comma negative 4. And there we have it. We just graphed a quadratic function. So I believe we have 2 more questions for the exam 1 portion of this. So let's just trek right through it. Question 7, now we're dealing with absolute value functions. And they give us our parent function and we're asked to graph this transformation. So our new vertex is at negative 2 comma negative 1. And the only transformation that's taking place is that horizontal shift to the left 2 units and that vertical shift down 1 unit. So negative 2 comma 1, our slope's going to still stay the same. Connect the dots. And then don't forget your arrows and you're good. probably label the graph too. G of x is equal to absolute value of x plus 2. This one. Done. I think I graphed it up here, but I should have just put it on the separate graph down below. So I'm just going to take this, copy, and then just put it at -2, comma, -1. Hope that the dots align. They don't. All right, I'll just redraw it. So there we go, much better. It says clearly label the x and y intercepts. So our y-intercept is at 0, 1. We have an x-intercept here at -3, 0. And then we have another x-intercept at -1, 0. And then last but not least, we're asked to find the domain and the range. Domain, we have no restrictions here, so it's all real numbers, -infinity to +infinity. Range, our absolute minimum, lies at -1 and then shoots up to +infinity. And we're done. One more question from this section. Our question 8, which deals with a piecewise function. And when you think about piecewise functions, just think about a bunch of different types of functions and then piecing them together, grouping them together. So you want to find the graphical representation of them separately first, but the x bounds are what varies. So maybe from -infinity to, I don't know, 100, we have a linear function. And then from our -100 to 5, we have, or to -5, we have a quadratic function. And then from -5 to +infinity, we have a cubic function. That's quite complex for this level of mathematics, but I think you get the visual gist of it. Now let's look at a concrete example. We're given this piecewise function. Both of them are linear. And we're just asked to complete the table. So pretty straightforward. For all of our values where it is less than 1, so we are going to utilize our 2x. And then for all of our values that are greater than or equal to 1, we are going to utilize our x minus 2. And this whole is going to be an open circle utilizing the 2x again. Okay. So h of -2. -2 times 2 is a -4. So our coordinate point here is -2, -4. 2 times -1 is -2. So our coordinate here is -1, -2. 0, 2 times 0 is 0. So our coordinate is 0, 0. And then we have an open circle at 2 times 1, which is 2. So at 1, 2. Now let's look at our pink. 1 minus 2 is -1. 1, -1. 2 minus 2 is 0. 2, 0. 3 minus 2 is 1. 3 comma positive 1. And 4 minus 2 is 2. 4 comma positive 2. Last but not least, let's just plot these points. So -2 comma -4. We have -1 comma -2. We have 0, 0. We have an open circle at 1 comma 2. And then we have 1 comma -1. We have 2 comma 0. We have 3 comma 1. And we have 4 comma 2. So dots. And then let's not forget to write out h of x function. So h of x is equal to 2x when our x is less than 1, and x minus 2 when our x is greater than or equal to 1. Last but not least, let's make sure that we label our axes and put in a proper scale. We were going up incrementally by 1 unit each time. You want to make sure that you can really get all the points that you can get for our graphing problems. And then this last bit, they just ask us to find the domain, and we have no restrictions. So our domain is just simply all real numbers, -infinity up to +infinity. There we have it. That completes the exam 1 practice exam. And then I'll create another video covering our exam 2 practice. I hope this was helpful. Let me know if you have any questions, and I'll see you guys soon.